Hi there, welcome back to the formulaic approach. In this video, we are going to be discussing indices or exponents. And by the grace of God, at the end of this video, you'll be able to understand the concept of indices, solve exponential equations, even up to advanced level questions. Okay, so by the end of this video, I'll also drop this is my WhatsApp number so that you can reach out to me. You can reach out to me for more questions so that in order to test yourselves. I have a lot of advanced level questions on this topic so you can reach out to me. I'll send them to you and you will answer them. But I'm going to go from the scratch in this video so that you can go from known to unknown, exactly. So stick with me till the end, because even those of you that already understand that just can't solve advanced level questions, it's just a little bit of tiny details that you are missing here and there that is making it impossible for you to solve some things. So just watch with me and let's go ahead. So now, what is indices? What is exponents? Now they are basically the same thing, okay? All right, but you see, indices is the plural, okay? So the singular is index, all right? Index, the plural is indices, singular index. Okay, so they mean the same thing, and what that means is that an index is the short form of a number multiplying itself so many times, more than once. So for example, if 3 multiplies itself this time, times 3, what is 3 times 3 first? That's 9. If I multiply by 3, that's going to give me 27. If I multiply by another 3, that's going to give me 81, right? Okay, now the short form of writing this long expression is just writing the 3 raised to power, how many times? 1, 2, 3, 4. 4. Is that clear? So 3 raised to how many times it occurs? This is called the index of 3. Is that clear? Or the answer in index form. So what's the answer? We said it's 81. So 81 in index form is 3 raised to power 4. Is that clear? All right. So now, actually, so this 4 is going to be called the index or the exponent. Okay, but in recent times, not even in recent times, for a long time now, we have been calling it power. But actually, from the start, this used to be called, you see, this 3 raised to power 4 is equal to 81. Now, this 3 is actually the base. This 3 is the base. This one here is the index or exponent, while this one used to be called the power. Okay, but because we have transformed it to just say 3 raised to power 4, so we call this 2 power. So for the purpose of this video, we'll be using power. Okay, but actually this was what was called the power before. Do you understand? This is the power of this thing. All right, but let's not get into that. That's for another discussion. So now we understand what index is. Index is the short form of something. So what that is saying is that if I have something multiplying itself, if I have a times a times a times a continually like that, continually, then it can be represented as a raised to a particular n. Do you understand? Where n is an integer that represents, a positive integer that represents, for this expression is positive, okay? That represent the number of times a appears. This n will represent the number of times a appears, or how many a's we have in the expression. Is that clear? So that if I have 2 times 2 times 2 times 2 times 2 times 2 times 2, blah, 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 it will be represented as 2 raised to power 1, 2, 3, 4, 5, 6. 6 raised to power 6, and that is 64. All right, so but this is the index form. That's my point. All right, now there are some things that you must know in order to be able to solve questions. You must know the rules of indices. Then I will now give you the series for some prime numbers. Okay, in most of our questions we basically deal with these prime numbers: 2, 3, 5, 7. This first 4, or maybe even first 5, 11 in some cases, but most of the time you see 2, 3, 5, 7 in your questions. All right, but before we do that, let's learn the rules of indices. The rules of indices. Now, for the purpose of this video, I will not be writing, I will just be listing the name of the rule, you write them down, okay? But I'll be telling you what the rule says. Now, the first rule is called the multiplication rule. I don't want to be taking time to write. So the multiplication rule is just saying that if I have a particular index a raised to power a number m, multiplying another base a raised to power n, for example, it says that it should be written like this: a raised to power m plus n. And let's make sense of that. Let's say we have 3 raised to power 2 multiplying 3 raised to power 4. Okay, so what does this become? Now this can be written as 3 raised to power 2 can be written as 3 times 3, right? Times 3 raised to power 4 can be written as 3 times 3 times 3 times 3, right? So it is the same as saying 3, 1, 2, 3 is the same as 3 raised to power 1, 2, 3, 4, 5, 6 raised to power 6. So instead of expressing in full, why not just say that pick one of the threes and say it is raised to power 2 plus 4, which is 3 raised to power 6. Do you understand now? In which case that would be 3 raised to power 4 is 81. 81 times 3, 243, 729. So you see, as you express, if you express in full like this, it makes it too long. So this is a short way of expressing that. So that is rule number 1. Rule number 1 says that if you multiply the bases, multiplication of base is equal to addition of powers. Multiplication of base is equal to addition of powers. All right. Now, it also applies to fraction. If the power is fraction, for example, a raised to power 1 over m plus a raised to power 1 over n is the same as a raised to power 1 over m plus 1 over n, of course. So we're going to get into how we express powers in fraction. All right, now number 2 is division power, the division rule. The division rule says that if I have a raised to power m divided by a raised to power n, that it should be the same as a raised to power m minus n. Of course, it makes sense. Division is the opposite of multiplication. So if I say a raised to power m divided by a raised to power n, then it should give me a raised to power m minus n. That is, division of base is equal to subtraction of powers. Exactly. Division of base equal to what? Subtraction of powers. In as much as the bases are the same. Keep in mind that these bases must be the same. If it's a and b, this does not apply. That is, a raised to power m divided by b raised to power n is not equal to a b raised to power m minus n. No. All right. So we can prove this. Let's try this. So for example, if I say 3 raised to power 3, maybe raised to power 4 divided by 2 raised to power 2, for example, then if it were equal to this, then I'm saying that it would be equal to 3 times 2, 6 raised to power 6, and that is not the case. All right, so because this one is 3 raised to power is 81 divided by 4. All right, so you see they are not alike, right? So that is what I am talking about. So that's division rule for you. That's division rule. So now the second rule, the third rule that you should learn is called the zero power rule, or the zeroth power rule. If I have the zero power rule, it says that a raised to power 0 should be equal to 1, no matter what a may be. A raised to power 0 is what? 1. 0 raised to power 0 is also 1. Exactly. So a raised to power 0 is 1. And let's make sense of that. Look at this. If I have 3 raised to power 4 divided by 3 raised to power 4, for example, now this should become 3 raised to power 4 minus 4. That is 3 raised to power 0, which is what? 1. If the rule stands, 3 raised to power 4 gave us 81, right? Divided by 81. 81 divided by 81 is what? 1. Do you understand now? So the rule holds for any number. Any number raised to power 0 is what? 1. Now let's go. How about the next rule? The next rule will be the, let's talk about the fractional power rule now. When the power is a fraction, how do you evaluate that? For example, if I have 1, a raised to power 1 over n is the same as the nth root of a multiplied by 1, raised to power 1 rather. raised to power 1. So what that means is that if I have a raised to power m over n is the same as mn, yes, let's do it this way. Okay, m is on top, n is under, so it's the same as the nth root of a all raised to power m. That's what this thing is saying. Is that clear? That is a raised to power 1 over n is the same as mth root. So that is the denominator becomes the root, the numerator becomes the power. All right, let's make sense of that using a question. For example, I have 64 raised to power 1 over 3. Is the same as the third root of 64 all raised to power 1. Makes sense? So what's the third root of 64? That's 4, right? 4 times 4, 16. 16 times 4 is 64. So we have 4 raised to power 1 is 4. Does that make sense? All right. But what if I have something like 125 raised to power 2 over 3? So when you have a number like this, 5, you know it's in 5 family, right? Or the family of 5. So this becomes the third root still of 125, but this time raised to power 2. So this becomes, what's the third root of 125? Is going to be 5, because 5 times 5 is 25, and 5 times 5 is 125. Then squared, is it clear? So 5 squared will now give us what? 25. Is it clear? So this power, this numerator becomes the power, denominator becomes the root. Is that clear? That's what the fractional power rule says. Fractional power rule. Alright. The next rule we should look at is the negative power rule. Number 5. Let's look at the negative power rule. The negative power rule says that if I have a raised to the power of minus m, a raised to the power minus m, that it is the same as 1 over a raised to the power m. Is that clear? So for example, if I have 10 raised to the power minus 1, right, it's the same as 1 over 10. Okay? If I have therefore have 10 raised to the power minus 2, it's the same as 1 over 10 squared or 1 over 100. Is it clear? Alright. So that is negative power rule. Now what if it were a fractional negative power? The same thing applies. If we have a raised to the power minus n over m, it will become 1 over a raised to the power n over m, which will now transform into the power, the fractional power rule. That is, we will have 1 over the mth root of 60 of a raised to power n. All right, I thought of using an example that way. If I have, for example, this our 64, whatever question I used the other time, which question did I use? Let's use 32 raised to power 2 over 5. 32 raised to power negative 2 over 5, for example. This will become 1 over, this negative means is inverse of this guy. Do you understand? 32 raised to power 2 over 5. This now becomes 1 over the fifth root of 32 all raised to power 2. This now becomes 1 over the fifth root of 32 is 2. Then raised to power 2. So we have 1 over 2 squared is what? 4. So that becomes our answer. Is that clear? Good. Now the next rule is the rule of we have no negative power. Now what if I have a base unit, or a unit base rather, unit base rule. If I have unit base, say 1 raised to power m is what? Is always 1. Is that clear? 1 raised to power m is 1. That's the rule of base unit. 1 raised to power anything is 1. Now, number 7th rule now says that what if I have a negative unit base? If I have a negative unit base like this is one thing you should take note of. Like this, raised to power m. There are 3 possibilities of answer we can get. Now, we can get the following possibilities. This will write it. We will get 1 if our m, this m, if this m is a, if m is a positive, if m is positive, if this m is, if even number, sorry. That's what I wanted to remember. If m is even number, then you get a negative 1 if m is odd number. I'll explain that if you don't understand. Then you will get infinity if m is a fractional. If m is a fraction. Okay? Alright, so now what's this? What this is saying is that if I have minus 1, for example, raised to power 3, is 3 an odd number or an even number? 3 is an odd number, so it will become minus 1 times minus 1 times minus 1. So minus times minus plus, plus times minus is what? Minus. So 1 times 1 times 1 is 1, so we get a minus 1. Is that clear? But the moment I change it to an odd number like 6, an even number like 6 rather, what will happen? It will become minus 1 times minus 1 in 6 places. Let me just show you that. 1, 2, 3, 4, 5, 6. Minus times minus plus, plus times minus minus, minus times minus plus, plus times minus minus, minus times minus plus. So plus 1, that's 1. Is it clear for even number? Now, but if I have negative 1 raised to power half, it gives you infinity. Is that clear? All right. Now let's go to the next rule. Now, another rule that we have probably not discussed is we've done negative power, we've done identity, yes. Now, what if I have multiple power? Multiple power rules. So, for example, I have a raised to power m, still raised to power n, for example. Then this becomes a raised to power mn. So that is m will multiply n, and that becomes a raised to power m indeed. Is that clear? Good. Now the next rule that we should discuss is what if I have a raised to power because we've done division there. A now what if I have now the multiplication of different bases but similar power. Multiplication of different bases but similar power like this. A raised to power m times b raised to power m. We've not discussed this. We've not. So is equal to, now is the same as a raised a multiplied by b all raised to power m. That becomes ab all raised to power m. You will discover that it is not ab raised to power m plus m. No, because they have similar power, I could easily just take both bases, multiply them together, and raise it to the same power. Let me give you a proof for that one. So, for example, you have something like 3 raised to power 2 multiplied by 2 raised to power 2 is the same as 3 by 2 all raised to power 2, and that is 6 squared, which is what? 36. Now you could prove that here. 3 squared is 9, by 2 squared is 4. 9 by 4 is what? 36. Do you understand now? So that shows you that this rule is valid. The rule is valid. How about division? Number 10 rule says that if I have a raised to power m divided by b raised to power m. Now this rule says that it should become a raised to power m over b raised to power m. They are the same, right? Since the powers are the same, then I could easily say that a over b all raised to power m. Just the same way as we did for multiplication. That is, we take the bases together and raise them to the same power. So if the relationship between them is division, divide the bases and then raise it to the powers. Is it clear? All right. Let me give you another rule. The inverse power rule. Okay, I've done that before, right? Yeah. This one, I just wanted to show you that if I have something like this, a raised to power a over b raised to power a over b raised to power minus n, for example, is the same as b over a raised to power m. How did this change? Remember, that minus negative power rule says that we should take it as 1 over that base. The base now is this fraction, so it will be 1 over a over b. Okay? All raised to power, this guy rather, raised to power m. Either way you put it, raised to power m. So 1 over this guy raised to power m. So if that be the case, then we have 1 divided by a raised to power m over b raised to power m. That becomes 1 times b raised to power m over a raised to power m. So by the time you have it, 1 times this is this, so that becomes b over a all raised to power m. Is that clear? Alright, so for now, I think this should be enough rule for us to solve questions with. So let me write some questions on the board for us to use as examples, and you see the way I will resolve them. Alright, now let's solve these questions. But in order to be able to solve this question, you must not first know this series offhand. 2 raised to power 1, 2 raised to power 2, up to 2 raised to power 10. Is that clear? Let me just give you here. 2 raised to power 1 is 2, 4, 8, 2 raised to power 4, like that, okay? We have it up to 16, 32, 2 raised to power 5, 2 raised to power 6, 64, 1, 2, 8, 2, 5, 6, 5, 1, 2, 1, 0, 2, 4, 2, 0, 4, 8, like that. I think this is 2 raised to power 10. So you should know it to this point. For 3, you don't need to know too much. Just know 3 to power 1, to power 2, to power 3, to power 4, to power 5, or thereabout. This will give you 3, 9, 27 by 3, 81 by 3, 243. You can go further, but if you know it to 3 is okay, to 5 is okay. For 5 also, 5 raised to power 1, 5, 2, 5, 3, 5, 4, 5, 5. If you know it like that, it's enough. Is that clear? 5 raised to power 5, 5 raised to power 1, 5, 2, 25, 3, 1, 2, 5, 4, 6, 2, 5, 5, 3, 3 something. I think 3, that's 25 times 5, that's 125, 3125. All right, so know that series for those 3, 5, and because most of my questions here are centered around 5s and 2s and 3s. So I told you most of the questions will be on this, the families of these prime numbers. Okay, so you must know how to target them. So for example, I have number 1 says 75a raised to power 3 b raised to power minus 2 divided by 15a squared b minus 3. Now what do? The first thing you want to do is, now looking at this, these bases are not the same. So you bring them together by division. So it becomes 75 divided by 15. But A is here. So this one, let's open a bracket for it because they are the same. So it will become a raised to power 3. Division of the bases means subtraction of the powers, right? I'm picking A and A together now. So it will be subtraction of their power. Then multiplied by B also, which is here raised to power minus 2. Then since the bases are being divided here, because B is repeating itself here. So I'll say minus, then minus 3. I hope this is clear. Why did I not pick one of these? Because the numbers are not the same. This 75, this 15. So I brought them together. So here 1, here 5. So I have 5 into brackets. Here I'm going to have a raised to power 3 minus 2 is 1. Then times b raised to power minus 2 plus 3. That is 3 minus 2, which is also 1, right? So 5ab. That is the final answer. Now what about number 2? Number 2 says that 5 raised to power 1 over 2 multiplied by 64 raised to power 1 over 3 all over 5 raised to power minus 3 over 2. So what do we do here? Let's express them in their simplest bases. Okay, so I can express 64 in the base of 2 or 4 if I care. But I like 2. So it's 2 raised to power 6 now. Give me this, right? So I can re-express this as 5 raised to power 1 over 2 multiplied by 2 raised to power 6, that is 64 first. Make sense? Then it's now raised to power 1 over 3 again. Is it clear? All right. So if that's the case, then I'll now put divided by 5 raised to power minus 3 over 2. Is it clear to you? 5 raised to power what? Minus 3 over 2. So here I can combine this one together. Division of the bases. Is that clear? Division of bases means subtraction of power. So I can pick one and say 1 over 2 subtracted by minus 3 over 2. I hope that is clear. Then multiplied by, now looking at this, if you remember a raised to power m, all raised to power n, it means a raised to power n times n. So this one is a fraction here, so it becomes 2 raised to power 6 times 1 over 3. So 3 can take care of here, it gives us 2 here. Does that make sense? So by the time you solve this, it becomes 5 raised to power 1 over 2 minus times minus plus 3 over 2, then multiplied by 2 squared. Makes sense? That's 4. So we have LCM, you take 4, 2. So by the time you solve that, it's going to be 4 over 2. If you solve this fractionally, 5 raised to power LCM is 2, 2 into 1, 1 times 1, 1 plus 2 into 1, 1 times 3, 3. Okay, that gives you 4 over 2. So 5 raised to power 4 over 2 multiplied by 2 squared, that is 4. Okay, this becomes 2 here 1, 2 here 2. So 5 squared is 25 times 4, that is 100. All right, then number 3. All right. Let's go to number 3. I thought the video stopped. Let's go to number 3. Number 3 says that 4 by 4 raised to power minus n multiplied by 2 raised to power 2n minus n. Minus 2, sorry. So if you have this, very simply what you do is this. Now you can reduce all of them to their bases, their individual bases, like this. This becomes 2 raised to power 2 times 2 raised to power. But of course, you wouldn't even need to do that. Do you know why? Because these are already the same. So since they are the same, you can easily just say 4 times 4, pick 1 4 raised to power. What's the power of 4 here? 1, right? Multiplication of base means addition of the power plus minus n. Is it clear? Then multiplied by 2 raised to power 2n minus 2. I'll teach you how to simplify this when I get to exponential equation now. So this becomes 4 raised to power 1 plus times minus n multiplied by 2 raised to power 2n minus 2. So if this be the case, then what is 4? If you express 4 is in the family of 2, so it becomes 2 raised to power 2, that is 4. This is 4, I'm writing 4 first. Then raised to power 1 minus n. 1 minus n multiplied by 2 raised to power 2n minus 2. I hope this is clear. So if that is clear, then I can have, let this multiply this, but it has to multiply everything that is here. Is that clear? This multiplies this one that is outside here, so it becomes 2 into bracket 2 times 1, 2. 2 raised to power 2 times 1, 2 minus 2 times n, 2n multiplied by 2 raised to power 2n minus 2. Looking at this, multiplication of base means addition of power, so I have 2 raised to power 2 minus 2n plus, I put in brackets, addition of 2n minus 2, addition of that power. So it becomes 2 raised to power 2 minus 2n plus, open this bracket, 2n. It doesn't affect anything, plus and minus is still minus 2. This and this cancel out to give 0, right? This minus this cancel out also to give 0, right? So 2 raised to power 0 is equal to what? 1. And that is the answer for number 3. Now let's solve the next one, number 4. Now number 4 is, number 4 cannot, okay, that's number 4, okay. Number 4 says 1 over 3 raised to power 5n times 9 raised to power n minus 1 times 27 raised to power n plus 1. Okay, so how do you solve this? Now very simply, what you do is this. What you will do is this. you will express it as in their basis. Express them in their basis. In what family will 3 belong? 3, 9, 3, 27, 3. Is that clear? So that's why I first give you these numbers so that you know how to express them. Now, but remember, when this is like this thing means, this inverse means 3 raised to the power minus 5n. Because remember, I told you that 1 over a is the same as a raised to the power minus 1. Right? So if it's 1 over a raised to power m to be a raised to power minus 1 times that m, that will be a raised to power minus m. So rather than just say this, if I have a raised to power minus m, it becomes 1 over a raised to power m. Is that clear? So next time you just express from here, just go directly to this place. Is it clear? All right. So that's what I did here. I basically went from here to that place. So I now have multiplied by, what is 9? Let's express 9 first. 9 is 3 squared in terms of this base, okay? So 9 is 3 squared. Now, this 3 squared is now raised to the power n minus 1. Multiplied by, what is 27? It is 3 cubed. That's 27. Who is messaging? So, 27 is 3 raised to the power 3. Then now raised to the power n plus 1 again. Make sense? Good. So all the bases are now the same. Okay? But let's first express them well. Let's express them well first. That is, let's expand this expression here. It becomes 3 raised to the power minus 5n times 3 raised to the power, this will multiply this, right? 2 times n, 2n, minus 2 times 1, 2. You see, the mistake some students make is they just multiply the first one. They don't multiply the second one. Don't make that mistake, okay? So we have multiplied by 3 raised to the power, this will open the bracket as well, 3n plus 3. So bases are not the same all through. I have 3 raised to the power, addition of powers, right? Minus 5n plus 2n minus 2 plus 3n plus 3. Then you might begin to ask that, why am I putting them in brackets, even though plus will not affect? The reason is, I want you to make it a practice so that by the time it is minus, it is division, when it will become minus here, you also remember to do so, because that minus will change, will affect something there. So we have 3, therefore, raised to the power minus 5n plus 2n minus 2 plus 3n plus 3. I just opened the bracket again. So it becomes 3 raised to the power minus 5n plus 2n plus 3n. We just, let's correct it like that. 3n plus 2n is what? 5n minus 5n, 0. So this takes care of this. So I now have 3 minus 2, which is 1. 3 raised to the power 1, that's 3. Is that clear? All right. Now let's go to the next question, which is number 5. So don't worry, I still have many questions that are like this. So just reach out to me on that number, and I am going to send you the questions for you to practice with. That's my WhatsApp number. All right, let's go. The next one says x. That's number 5. X or x is by a over x is by b raised to power a plus b multiplied by x raised to power b over x raised to power c b plus c x raised to power c over x raised to power a c plus a. All right. Now looking at this, see, the first way to express this one here is to bring them together. Division of bases means what? Subtraction of power. Since the bases are equal, becomes x raised to power a minus b. Is it clear? Subtraction of power. So by the time we have this will now be raised to power. Okay, look at something here. I can just bring this here, then raised to power a plus b. Is this clear? So this will now be multiplied by x raised to power raised to power b over, so the same way, x raised to power b minus c, right? Then raised to power b plus c, okay. Do you see what I'm saying too? That it is x raised to power here, c minus a, then raised to power c plus a. So we have difference of 2 squares, the expression that that gives us difference of two squares. What's the difference of two squares? If I have a plus b multiplied by a minus b is the same as a squared minus b squared. Just know that take the first one squared minus the second one squared whenever you have an expression like this. Is that clear? Good. So let's do that here. So this becomes x to the power So now, what are exponential equations? Exponential equations are just equations that include indices and have equality sign, okay? So we call them exponential equations. We can always solve for a particular power that the unknown is a power. Do you understand? So if an unknown is a power, then it becomes an exponential equation. So let me give you some 2 or 3 rules that you can use to solve exponential equations. The first one is what we call I will call it the equal power rule. Equal power rule. So if the powers are equal, then the bases are equal. So for example, if I have a raised by m being equal to b raised by m, if I have this, then if this is the case, then A must be equal to B. Equal power rule. If the powers are equal, for example, think of it too. If I say a particular number raised to power 3 is a particular number raised to power 3, so definitely this number must be this number. If a particular number raised to power n is another number raised to power n, then the numbers must be the same. Is that clear? The second rule is equal base rule. If I have a raised by n equal to a raised by n, then n must be equal to m. And that makes sense also, because if I have a raised to power n, a particular number raised by n, and that same number raised by m, and I say they are the same, then the powers must be the same. Exactly. Then the other one is reciprocal power that I want to talk about. Look at this. If I have a raised by m being equal to b, for example, to make this, to find what a is, I will multiply both sides by the reciprocal of this power. So that becomes a raised by m. What's the reciprocal of that power? M is 1 over m, right? The reciprocal is 1 over m. So that becomes a raised by m times 1 over m is equal to b raised by 1 over m. I've multiplied both sides by that reciprocal. This will take care of this so that it will be left, a will be left alone here, and it will be equal to b raised by 1 over m. Is that clear? All right. Let's solve some questions in order to put this in good context. So for example, I have 2 raised by x plus 2 raised by x is equal to 16, for example. Looking at this, now this is, if I say 2 raised by x, if I call it b, this is like saying b plus b is equal to 16. Does that make sense? So that 2b is equal to 16. Make sense? So then I can divide both sides by 2 over 2, here 8. So b is now equal to 8. But remember that b is 2 raised by x from what I did, right? So if b is 2 raised by x, recall that b is 2 raised by x. So 2 raised by x is now equal to 8. So I will now say 2 raised by x is equal to 8 in terms of 2 is what? 2 raised by 3. So if the bases are the same, the powers must be the same. So x equal to 3. So don't cancel. Don't come and say 2 here, 1, 2 here. No. The rule says that if the bases are the same, the powers must be the same. And it doesn't make sense to even come and cancel here. It's not, you are not dividing both sides by 2. Is that clear? Let me prove that to you. What I'm saying is that you should not do like this. The reason is this. You are saying that we are dividing both sides by what? By 2. If you divide both sides by 2 here, what? Watch. This will become 2 raised to power x raised to power minus 1 equal to 2 raised to power 3 minus 1. So you have formed another equation. So next time, just equate the powers. Equate the powers. All right. So now let me write other questions. Let me write like 3 or 4 questions here. And we'll solve. And we'll call it a day. Now, I'll try to speed things up here. I have 8 questions to solve that are very simple as well. So let's go to number 1, which says square root of 3 times 27 x raised to power x, 27 raised by x plus 1 equal to this. So I'll express them in terms of the base of 3, right? Everybody here is in family of 3. So this becomes 3 raised to power 1 over 2. Makes sense? Square root of 3 times 3 raised to power 27 is 3 raised to power 3. then all raised to power x plus 1 is equal to 9 is 3 squared, then all raised to power 9x plus 1 is equal to 2x. You must be sure not to write the wrong question. Is that okay? So I have 3 raised to power 1 over x, 1 over 2, then multiply by 3 raised to power this by this, 3x plus 3 is equal to 3 raised to power this by this, 4x plus 2. So I can take 1 here and say 1 over 2 plus 3x plus 3 is equal to 3 raised to power 4x plus 2. Since the bases are now the same, then the powers must be the same. So these powers are the same. I have half plus 3 because it becomes 3 and half plus 3x. The powers must be the same if the bases are the same. So plus 3x is equal to 4x plus 2. All I simply did was to add the power. Exactly. So I can take this one here and bring this guy here. It becomes 3 and half minus 2 is equal to 4x minus 3x. Is that clear? Brought this guy here, brought this guy here. So if you subtract, you get 1 and half here is equal to this plus this. This minus this is x. X is 1 and half or 3 over 2. Alright. For number 2, we have 3 over 5 all raised by x is equal to 5 over 3 all raised by 3. Alright. So this one is very simple. Look at it. Since this 3 over 5, this 5 over 3, let's invert it. If we invert this, this becomes 3 over 5 all raised by x is equal to 3 over 5. But by the time we are inverting it, it means we'll put minus here, right? This by minus 3. So bases are now the same, powers must be the same. X equals minus 3. For number 3, we have 10 raised by x is equal to 0.1 is the same as 10 raised to power minus 1, right? Because 0.1 is 1 over 10, and 1 over 10 is 10 raised to power minus 1. So I'm expressing everything in terms of 10 as the base. So multiply by 10 raised to power what will give me 100. That will be 10 raised to power 2. Into bracket x minus 1. Is that clear now? So this becomes 10 raised by x is equal to 10 raised to power minus 1 times 10 raised to power 2x minus 2. By the time you work that out, and this becomes 10 raised to power x is equal to, pick one here, becomes 10 raised to power minus 1 plus 2x minus 2. Minus 1 minus 2 is minus 3, so I have 10 raised to power x is equal to 10 raised to power minus 3 plus 2x. So now I can say bases are the same, powers must be the same. X is now equal to minus 3 plus 2x. Bring this one here, bring this one here, or bring this one here. Becomes x minus 2x, bring this one here, is equal to minus 3. Okay? So from here, I can have minus x is equal to minus 3. So x equals 3. Alright. So for the next one, number 4. This one says, this thing roots this. Now that will become, I can express that as 64 raised to power, now you know there is a power here. If you remember this rule, that m to root of a is same as a raised to power 1 over m, right? Okay, so if I have this root of this, then it becomes 64 raised to power 1 over that expression 2x plus 3. Is it clear now? Then that is equal to 128 raised to power, this is a power here, so it becomes 2 over that expression 6 minus 2x. I hope I have not confused you. So from here, I can now go on to saying that I can express this in terms of 2 if I want. So 2 raised to power what to give me 64, 2 raised to power 6, all raised to power 1 over 2x plus 3. Then is equal to 2 raised to power what to give me this 64 times 2, that's 120, that's 2 raised to power 7 into bracket 2 over 6 minus 2x. So by the time I have this, I will say 2 raised to the power 6 over 2x plus 3 is equal to 2 raised to the power 14 over 6 minus 2x. Bases are the same, powers must be the same. So I have 6 over 2 plus 3 is equal to 14 over 6 minus 2x. You cross multiply. Or you can even divide, like 2 here, 3, 2 here. Okay, let's just cross multiply. That will become 14 into bracket 2x plus 3 is equal to 6 into bracket 6 minus 2x. Is that clear? So here I can cut 2 here 7, 2 here 3 to make things easier. Is that clear? So 7 will now open the bracket, becomes 14x plus 21 is equal to 18 minus 6x. Bring this one here and take that one there. Becomes 14x plus 6x is equal to 18 minus 21. This plus this gives us 20x is equal to this minus this minus 3. X equals minus 3 over 20. Alright. Then for the next one, this one is very simple. So just easily express. I have many more questions like this, okay? That's why I asked you to reach out to me. Now, just express that guy as in family of threes. So, for example, that 81 will become 3 raised to the power 4, right? That's all give us 81. Into brackets, everything here. Into bracket 5 minus 2x, right? Then multiply by 3 raised to power 3 raised to power, what give us 243? That's 3 raised to power 5 now. Be sure. I'm sorry, my microphone stopped the other time. 5 into bracket x minus 2. So is equal to 1 over 3 is 3 raised to power minus 1 over, this is 3 squared, right? 9 is 3 squared. That will be 3 squared into bracket 5x minus 1. So this becomes, pick one here, right? So that becomes 3 into bracket 20. I'm expressing it fast, okay? 20 minus 8x plus 5x, this times this, minus 10, all over 3 raised to the power 10x minus 2 is equal to 3 raised to the power minus 1. Bring this and this together to be minus, right? It becomes 20 minus 10 is 10, minus 8x plus 5x minus 3x, right? Then minus these ones. That will be 10x minus 2 is equal to 3 raised to the power minus 1. Is that clear? Bases are the same, powers must be the same. So I have 10 minus 3x minus 10x plus minus times minus plus 2 is equal to, powers must be the same, minus 1. So I have minus 13, 10 plus 2, 12 minus 13x is equal to minus 1. So 12 will go there, we have minus 13x is equal to minus 1 minus 12. Minus 13x is equal to minus 13. X equals 1. Is that clear? Alright, so you see that's very simple. Now, here is now the ones that leads to, well, these are fine questions now. Let's solve number 6 now. I want you to look at where I'm going to solve it. I want you to look carefully at where I'm going to solve it. I have number 6. 4x squared plus 2. This power of power, okay? Okay, I didn't give you that rule. Power of power, but it's pretty much easy. Just what? Equal to 9 times 2x squared plus 2. Now let me show you something here. I can express this as 2, right? In terms of 2, that becomes 2 raised to power 2 raised to power 2 raised to power 2 into bracket x squared plus 2, then plus 8 is equal to 9 times 2 raised to power x squared plus 2. So if this is the case, then I have 2 raised to the power 2x squared plus 4 plus 8 is equal to 9 times 2 raised to the power x squared plus 2. All right. So I can if I bring this guy here, no, there's something else coming to my mind. I've not solved it before, so, but it's simple. Just watch, just watch. See, this now I can re-express it as 4x squared, 4 is by x squared multiplied by 4, 4 squared. Do you agree now? 4 squared. Is that clear? Then plus 8, because I want to express this together, it becomes 4 is by x squared plus this 2. Make sense? Is equal to 9 times 2 raised by x squared. This one becomes plus 4 multiplied by 4 because it's 2 squared. Multiplied by 2 squared, that will be 4. All right. So if that's the case, then let's bring this one. Let's take it to that side. So that 8 becomes 9 times 3 raised by x squared multiplied by 4 is equal to, minus 4x squared multiplied by 4 squared. You might be asking why I put it to that side. It's because I'm noticing that 4 is common, right? So I was thinking if I could collect like terms. Sorry, I'm not writing it correctly. X squared, please. All right, now watch. Watch. There's something else I could do here. So I could say that let 2 raised to power x or 2 raised to power x squared. Let's make it d. Is that clear? 2 raised to power x squared, let's make it d. So if we make it d, let's first re-express this one in terms of that 2. This becomes 8 equal to this times 2 raised to power x squared. This times this will become 36, right? That is 36 2 raised to power x squared minus, this is 64 squared, that's 64 and 16, sorry, times 4 raised to power, now this will now be 2 squared into bracket x squared. So, do you understand now? 4 is 2 squared. So I could bring this one here. If I write this, this becomes 2x squared times 2. So this 2 raised to power x squared is this, right? You know this thing and this thing are the same, right? So if they are the same, then if I make 2 raised to power x squared d, then 8 becomes 36d minus 16. This is now d, this here is d. Then raised to power 2, that's d squared. Is that clear? So by the time I solve, let's make it positive. It becomes 16d squared. Bring this one here, bring this one here. Minus 36d, then plus 8 is equal to 0. Divide both sides. Let's divide through by 2 so that it becomes easy. Divide through by 2. No, let's divide by 4, sorry. 4 is faster. So I'll have 4d squared minus 9d plus 8 plus 2, equals 0. So let's solve quadratically. It becomes 4d squared minus 8d minus d. Just solve by quadratic equation. Multiply this guy by 1, 8. So it's 8 times 1 minus 8 times minus 1. That will give us 8. So substitute that here. It becomes this. Then plus 2 equals 0. So I have factorized. So I have 4 is common, d is also common. So I have d minus 2 here, d minus 2 also here, plus 1 here. So d minus 2 is common between 4d and plus 1 equals 0. If this times this gives 0, is either d minus 2 is equal to 0 or 4d plus 1 is equal to 0 for both of them to multiply and give 0. So if that's the case, d here equals 2 or minus 1 over 4. So let's now apply that into our expression that we. Now you remember that, recall that we said that d should be 2x raised to power 2. Now we said d is 2, so 2 equal to 2 raised to power x squared, where d is 2 now. Therefore, if the bases are the same, then the powers must be the same, 1. So x squared must be equal to 1. So x must be equal to the square root of 1, which is equal to plus or minus 1. Or where d is minus 1 over 4. So that becomes minus 4 raised to power minus 1 is equal to 2 raised to power x squared. Okay? So it becomes minus 2 raised to power minus 2 is equal to 2 raised to power x squared. Now looking at this, these bases are not the same. These bases are not the same. How do I know that they are not the same? One thing you can do here is to say minus 1 times 2, both raised to power minus 2, so that you now say minus 1 raised to power minus 2 times 2 raised to power minus 2 is equal to 2 raised to power x squared. But of course, there's nothing much you can still do here. So d is not minus 4, and d is actually 2. So that's the best bet. So our answer x is plus or minus 1. Alright, so that's that for that question. If you wanted to solve further, or if you need some further solving, you can reach out to me on that, on WhatsApp. The video is already long, so I'm trying to make it short as possible. This one, I will just explain what you will do. Let me show you the second one. That second one is also very simple. You have 9 to the x plus 6 to the x is equal to 2 times 4 raised by x. Just follow my step. Break it down to the bases. So what's the base here? 3. So 3 squared is what we have here, then raised by x, right? Plus 2 here times 3. Both of them raised by x is equal to 2 times 2 raised by 2x, 2 squared x. Makes sense? So this becomes 3 squared x plus. Now looking at this here, you say it will be 2 raised by x times 3 raised by x is equal to 2 times 2 raised by 2x. Make sense? So from here, we can collect like terms. Looking at this, you will see that 3 raised by x is common, right? Or which one should we do? We bring this and this together. Let's collect like terms here first. 3 raised by x is common between 3 raised by x will be left here. Then plus 3 raised by x, remain 3 raised by x here is equal to it doesn't really help much. You know what you do? Simply substitute. So we say let 3 raised by x be d, and let 2 raised by x be, let's use m for that one. So if 3 raised by x is d, you know that this 3 raised by 2x is the same as 3 raised by x times 2. So 3 raised by x is now d, becomes d squared. So d squared plus 3 raised by x is m, plus m times 3 raised by x d is equal to 2 times 2 raised by 2x is the same as 2 raised by x, which is m. Where is m now? M squared. Is it clear now? So by the time we solve this, this becomes d squared plus dm minus 2m squared is equal to 0. By the time I bring this guy here. So to solve quadratically, now here you say 1 here multiplies this guy becomes 2. So what are the factors of this guy that will give us that guy? Factors of this guy, those are 2 and 1. So it will be plus and minus that will give us plus this. Right? I'll try to multiply them to give you this. So we have to put dm here, right? Dm. And then we'll put dm, it becomes d squared plus 2dm minus dm minus, so I've substituted this guy, minus 2m squared is equal to 0. Let's now factorize. So by the time you factorize, you will have, let's bring it up here, you will have d is common. D is common between 1d plus 2m. D plus 2m. You find out that that's what you also have here. D plus 2m. So what we use to multiply that will be m. So minus m. So if you give it to give you md or dm minus 2m squared. So everything is equal to 0. So I have d plus 2m is now common between d and minus m. So both are equal to 0. So d plus 2m is equal to 0 or d minus m is equal to 0. So it's either d equals minus 2m or d equals m. So where d is m, what is d? What is d? What is d? D is 3 raised by x and m is 3 raised by x. So in this case, you say that 3 raised by x is equal to 3 raised by x. So if these bases are the same, if these powers are the same, then but 3 is not 2, right? 3 is not 2. But using the power rule, using the power rule, using the power rule, 2 is not. But we also know that this is, d is also, this 3 raised by x from here is also equal to 2, negative of 2 times 3 raised by x. Okay? So from here, how do we get an expression for x? You can simply introduce logarithm. So if you introduce logarithm from here, we have log of 3 raised by x. I've not even showed you the relationship between them though. 3 raised by x, so x log 3 is equal to x log 2. So from here, we'll have to find what log 3 is and what log 2 is. From here, if we say that Let me see what I can do. All right. I still solved it another way and arrived at this answer. So what will happen is that the expression when you have an expression like this, the next must be 0. And if you test it in, you see that 9 raised to the power 0 is 1 plus 6 raised to the power 0 is 1 is equal to 2 times, let's see, it must be equal to 2 times 4 raised to the power 0 is also 1. So 2 times 1, 2, 1 plus 1, 2, so 2 is equal to 2. So you see that x is actually raised to the power 0. So whenever you have an expression like that, the term must be 0 there. So what? To do this one, you express it the same way. It will be 3 raised by x times 3 times 3 raised by 1 over x here, right? So you now express, in this case, you let d be equal to 3 raised by 1 over x. Is that clear? Then for this case, you know there will be 2 here, 2 times 3 raised by 1 over x here. So it will be equal to 3 raised by 1 over x times 3 raised by 1 over x. So here you make m now be 3 raised by 1 over x. If you do it that way, you see that you get an answer just like we did here. Now, let me now show you the link between logarithm and indices like I promised. Now you see, logarithm is just the reverse operation of logarithm, of indices. Logarithm is just the reverse operation of indices. So if I say, for example, 3 raised to the power 4 is 81, for example. Now, I would say that, let me explain the meaning of logarithm first. Logarithm means, if I say what is the log of 81 base 3, the answer will be 4. Now, how did I get that? What does logarithm mean? Logarithm means what power will I raise this base to give me 81? Does that make sense to you? What power will I raise this to give me 81? So I've solved questions on logarithm before. I'll link the video in the description. So I won't be solving any question. I'm just showing you the link. So for example, if I say log of 1000 base 10 is what? It will be 3. How do I get that? You just say what power will I raise 10 to get 1000, and that's 3. So that's why their rules are also very, very similar. So do well to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. God bless you as you do so.